Hi everyone. Here is section 1.2, finding limits graphically and numerically. So before we start, just a few reminders. One, please pause where you need to pause in the video, okay? I will prompt you on when to do that, but feel free to do it on your own as well, or rewind and replay if you need to, because everyone learns at a different pace. So make sure that you're not moving on until you've understood what has happened there, okay? And a second reminder, please make sure that you're taking notes physically as it is a part of your homework. And I'll prompt you throughout the whole video on what to write and when to write it, okay? So first thing I want you to do is go ahead and write down the section here and your FLT. Your FLT is right here. Go ahead and write that down. Pause if you have to, but I'm going to go ahead and move on right here. Okay, here we go. So today, you want to know three things, okay? There are three things that you guys need to know in calculus. There are three big ideas, okay? You know, with your previous math courses, you guys were learning hundreds of different concepts. Not really for any particular reason, and it's really because you guys were working your way up to this class here, okay? The nice thing about calculus is that there's only three big concepts that you guys need to know. So knowing that there's only three, it's very conceptual. So make sure that you're asking a lot of questions. Check in with me during office hours if you need to. But really, there's three big ideas, and the first big idea is knowing what a limit is, okay? And then we're going to explore how to find a limit graphically and numerically, okay? So when this video ends, make sure you know what a limit is, know how to find it graphically and numerically, okay? I'm going to go ahead and move on. Okay, so the first thing, you know, when you guys read what a limit is in a textbook, it can get very confusing. So I'm going to break it down for you guys, okay? And while I'm writing this down, you guys should too, okay? Here's the definition of a limit. Let me change the font here. Okay, so a limit, I'll break it down into four parts. Okay, a limit is the y value, and make sure you're writing this down, as x gets arbitrarily close to some number a. Third one is on either side of a. Fourth one is but not exactly at a. Okay, so first what we're going to do is we need to know this. Okay, this definition is very conceptual, and you guys need to know all four lines here, okay? So you want to recite this to yourself, okay? And you want to say this as many times as possible. So again, it's the y value, okay? And I'll kind of illustrate this as we go. It's some y value, okay, as x gets arbitrarily close to that number, a, on either side of a, but not exactly at that moment, okay? It's the y value as x gets arbitrarily close to a on either side of a, but not exactly at a. So this is where I would ask you guys to pause and to say this out loud to yourself, okay? Make sure that you guys know these four lines. Go ahead and pause, and when you're ready, press play again, okay? Okay, here we go. So that's the limit. This right here is the actual definition, okay? So this can get a little bit confusing because there's a lot of verbiage here. All I want you guys to know is how to actually write a limit. Some of you may have seen this before. Some of you may not, but it's okay if you haven't seen it. This is how you write limit notation, okay? So I'll write this with you guys. If you guys had lined paper, okay, imagine that to be one line. The way you would write this is the limit of f of x. Notice how f of x is a little bit larger as x approaches a equals something. Okay, so practice writing it. Now, what I want you to do is practice saying it. So again, I'll repeat the steps. You're going to say the limit of f of x as x approaches a is L. Okay? Rewind that if you need to, but we're going to move on. Okay? So remember the 4 lines, okay? It's the y value as x gets arbitrarily close to a on either side of a, but not exactly a. So right now you guys are trying to memorize it, but what does it all really mean, right? So here's example 1. Go ahead and write this down. This is typically how you would see a limit problem. Here they have the limit. So again, the way you would say it is the limit of x squared minus x plus 2 as x approaches 2. Okay? So remember, we're trying to find the y value as x gets arbitrarily close to a on either side of a, but not exactly a. So we're trying to find some y value, okay? So your y value is like your output. As x gets arbitrarily close to, in this case, your a value is 2, okay? We're getting arbitrarily close to 2, but not exactly, okay? So here's what we're going to do. You're going to go ahead and turn on your calculator, okay? And we're going to play this game. So a few things about your calculator, okay? So what you're going to do here is right at the, well, first of all, I'm going to show you all the buttons that comes with this calculator. And you guys will learn it slowly, but the more and more you guys use it, the easier it's going to be to remember everything, okay? So first at the bottom left is the on button, okay? If you notice right above the on button in blue, in most cases, it says off. So all you would have to do is press the blue button, which is the second button on the upper left. And then you would press the on button to turn it off, right? So the calculator has a lot of features because there's all the blue buttons, all the regular buttons, and there's also even all the green buttons, okay? So you're going to turn this on, and to make sure that everyone's on the same page, I always encourage my students to reset their calculator, okay? So what you're going to do is you're going to press second, and I'll write it out here, second plus 712. I will encourage you guys to do this every single time. Second plus 712. So if you press those 5 keys, you'll reset your calculator. So here we go. I'm going to go ahead and press second plus 712. And you know you did it right if it says RAM cleared, okay? So remember, this is to reset your calculator so that everyone's on the same page. Oftentimes when you switch modes on a calculator, it could throw off how you calculate things. So this is just to make sure that there's no funny business, okay? All right, so the first thing we want to do is on the upper left, at the very top, there's a y equals button. This is where you get to type in all of your functions, okay? So in this case, we're dealing with the function x squared minus x plus 2. So right next to this alpha button to the right, you see a xt theta n. That is your variable button, okay? So here, you're going to press x squared, which is right here, minus x plus 2. And again, pause if you need time doing that, but I'm just going to move on at regular speed, okay? Just for the sake of keeping the video short. All right, so what you want to do now is you want to go ahead and go on to graph. if you want to see what the picture looks like, it'll graph it for you. So notice there in blue, if you don't have the colored version, you're not going to see the color blue, obviously, okay? But what we're going to do is right above graph, you see the blue word table. What we're going to do is we're going to try to access that. So we're going to have to press second and graph to get to our table, okay? So here's our table. They already have preset numbers in there. So if you plug in 0 into your function, you will get a value of 2, okay? If you plug in 6, you will get a value of 32. So they did this all for you. So the calculator speeds everything up for you here, okay? But what we're going to do is we're going to try to plug in our own values. So what you have to do here is right above the window button, okay, is table set. Sorry. So we're going to have to go to the second button, window, and what we're going to do is we're going to change our independent to ask, and then you press enter there, okay? Again, pause if you need to. I'm going to go ahead and go back to my table, which is second graph, okay? So if you noticed, it's blank now, okay? Again, pause if you're not ready to move on. So what we're going to do here is we are going to find the limit numerically, okay? So we are going to get as close to 2 as possible, all right? So remember, the definition is the y value as x gets arbitrarily close to 2 in this case, on either side of 2, but not exactly 2. So the thing is, let me draw a number line for you guys. If this is the number 2, think about what numbers are on the left and to the right of it, okay? So obviously, to the left of 2 would be 1, to the right of 2 would be 3, okay? So let's say I wanted to approach or get arbitrarily close to 2 from the left side, okay? So here, you're going to start at, let's say, the number 1, okay? I'm going to press 1, enter. Now, right now, I'm at 1, but the key word here is we want to get arbitrarily close. So can I get closer to 2 than just 1, right? So some of you may think, well, you know what, I can get a little bit closer. What about if I plug in 1.5? So I'm going to go ahead and do that on the calculator here. Okay. Now, what I'm going to ask you is, can you get even closer than that? And I hope the answer is yes, right? So I could actually go, well, you know what? I'm going to go to 1.9, which is right about here, right? I'm not going to bubble all of them, 1.9. Now, can you get even closer than that, right? You could actually go 1.99. Now, can you get even closer than that, right? You could even go 1.999. And we could do this all day. I'll actually go another digit over, right? So notice with your blue y values, right, as x gets really close to 2, you notice that the y values are getting really close to what number here, right? You notice that it's getting really close to the number 4. Notice how it's like 3.999, 3.997. It's getting really close. Now, the reason why I'm not going any further, and I'll show you here. Here I have 5 digits of 9. But when I type that in, notice how it says 2. Okay, now it's not 2 here, because if you actually go up, if you toggle up with the up arrow, it'll actually tell you what the exact value is. And the reason why it says 2 is because, well, there's not enough room to fit in all the digits there. So watch out for that. Make sure you gradually get close. Don't just jump straight to 1.99999, okay? Now I'm going to go ahead and delete that. So if you notice on the right, when I get really close to 2, when x gets really close to 2, it's looking like the limit is getting really close to the number 4. Okay? So I'm going to write this here. The limit of this function comes out to about 4 when I approach it from the left, okay? Now, remember the third line to the definition. It's the y value as x gets arbitrarily close to a on either side of a. So what we have to do is we actually have to check what happens when we get really close to 2 from the other end. Okay? So here we go. I'm going to go ahead and just press delete. Make sure you don't delete the x value, okay? Just delete those. And I am going to approach 2 from the right. So what's a good number to start from the right side of 2, right? Feel free to pause there and think about it. Okay, so a good number to choose is probably 3. Okay, so I'm going to click on 3. Now, think about it. If you're getting closer to 2, what's a good number that's closer to 2 than 3, right? So 2.5 would be a good one. Some people might say, well, you know what? I can go all the way to 2.1. Now, pause here if you need to. Can you get arbitrarily closer? What would be a number that's really closer to 2 than 2.1? Okay, so 2.01 is a lot closer. You can even go 2.001. You can even go 2.0001. And you could go all day, right? Now, if you take a look, I got really close to 2 from the right side. Now, look at your y values, right? As x gets really close to 2 from the right, the y values are getting really close to what number? Right? So I'm hoping you guys would have said that the limit comes out to 4. Okay? Now, what do you guys notice here, right? If I approach 2 from the left or from the right, are the limits the same? Right? And in this case, the limits are the same. So we could say that the limit is 4. Okay? Now, obviously, when you guys do this on your own, it's going to be a lot faster, but I want to explain everything for you guys, okay? Okay, so that's it. Okay, so here we go. This is basically what they have in the book, just to show you. As we got really close to 2 from the left, notice how these are all the values to the left of 2. These are all the values to the right. Now, we didn't use exactly the same values as they did, but it really doesn't matter, okay? Now, if you didn't have a calculator, you would have to do this all by hand, right? And that's not the point of calculus. So you want to make sure that we speed up all of the things that we really don't want to spend our time on, okay? Plugging and chugging is something that I don't want you guys to waste your time on, okay? So here we go. Graphically, remember, this was a parabola that you guys had, okay? Notice how when I got really close to 2, so I started at 1, as I got really close to 2, really close to it, I got something that was about a limit of a 4. And as I got really close to 2 from the other side, I noticed that I got a limit of 4 as well, which is why the limit came out to 4. Now, the fourth line of that definition is, but not exactly A. In this case, but not exactly 2. Some of you are thinking, well, why don't I just plug in 2 into my calculator to get 4? Okay? That's not the idea. And I'll show you where that will not work. Okay? Because the limit, the concept of a limit is you're studying the behavior of something of when it gets really close to it. Because sometimes what happens exactly at that moment, you might not get information for. Okay, so just keep that in mind. Keep that definition in mind. So here, I want you to see these three graphs here, okay? And you could sketch these, pause if you need to right now. Okay, so here, the limit of this blue function, f of x, as x approaches a, is this L. So there, that limit exists. This next one here, slightly different, but if you notice, there's a hole there, right? But again, a hole means that nothing is happening there, right? So does the limit exist as x approaches a? So the limit of this function as x approaches a still does exist. Now here's the reason why. If you guys remember that very last line, the fourth line, it says, but not exactly a. So even though nothing is happening in this hole, I know it's a little bit blurry, even though nothing is happening at that hole, we don't care about what happens exactly at that moment. But we still notice that when we get arbitrarily close, we still approach the same value on either side. Okay? And that's where it gets conceptual. We care about what happens when we get really close to it, but not exactly at that moment. Now here, there's a hole, but it's not even defined. So if you go back to this picture, sorry. Even though it's not defined at this hole, exactly at A, you get some random value down here. Okay? But down here, there is no value. So does the limit exist as x approaches A here? In this case, it still does, because we're just studying what happens when we get arbitrarily close on either side, but we don't care what happens exactly at that moment. So even though there's a hole there, the limit still does exist. So whether there's a hole there or not, right, the limit will still exist. Okay, and you guys will understand that more when we get into the next example here, okay? Okay, so here we go. Here's one for you guys to try, okay? So what you want to do here is first write this out, and then I'll pause. You should too if you need to. Turn on your calculator again. You're going to go back to your y equals, okay? And you're going to clear that function, erase it. Don't press delete, just press the clear button, which is on the right side somewhat, right below the up, down, left, right buttons, okay? So you're going to clear it, and you want to be careful with typing this one out here, okay? The calculator, although somewhat advanced, it's also pretty dumb, okay? So you want to type it out exactly how you want it to be inputted. So here, you notice that x minus 1 is all in the numerator, and x squared minus 1 is all in the denominator. Now, if you type out x minus 1 divide x squared minus 1, you're actually telling the calculator to type this out. Okay, that's what the calculator is reading. So what you have to do is you have to include parentheses around the numerator and also around the denominator. Okay? So go ahead and do that. Okay? Now, again, I encourage you guys to go through the lesson with a partner, as previously stated. So make sure that you practice this. So what you're going to do here is now you're going to play that guessing game again. You're going to try to get closer to that number. So in this case, what number are we approaching here, right? So according to this limit, what number are we approaching? So notice how we're approaching 1, okay? So I'm going to draw the number line here. And again, you guys don't have to. This is just for visual purposes. You're going to get really close to 1 on either side. So to help you, what would be to the left and to the right of 1, right? So hopefully you guys said 0 and then 2. Okay, so what you're going to do now, and I'm going to give you guys however long you need because this is a video. So pause this if you have to. Go to your table, clear your table, and get arbitrarily close to 1 on either side. Okay, so I'll give you a second to do that. And play whenever you're ready, okay? So if you're approaching 1 from the left, a good place to start is probably 0, and then maybe 0 0.5, and then 0 0.9, and then 0 0.999, and so forth, right? If you're approaching 1 from the right, you should probably start at 2, and then maybe 1.5, and 1.1, then maybe 1.01, or maybe 1.001. So if you did that correctly, your limit should have, notice how when we get really close to 1 from the left, it comes out to about 0 0.5. Okay, and if you approach 1 from the right, you get about 0 0.5 as well. Okay, so notice how they both have the same value here, okay? Now, if you didn't get that, and you're trying to figure it out, and if you still don't understand, definitely text me, okay? So here we can safely say that the limit here comes out to 0 0.5, otherwise known as 1/2, okay? You could write 0 0.5, but there's a reason why I'm writing 1/2, and that's for something for us to discover later, okay? Now, something that I want you to think about, go back to your table. What if you said, you know what? I don't want to type all this out. I'm just going to take a shortcut and I'm going to input the number 1. Now, I want you to take a look at what happens when you plug in 1. And what do you guys notice, right? When you plug in 1, there's actually an error. Now, why is that, right? So, 2 things. 1, remember, you're getting arbitrarily close but not exact. So you don't want to plug in 1 because that's not what a limit is, okay? So the reason why there's an error is for 2 reasons. If you take a look, if you plug in 1 here, your denominator will be a 0. And if you remember back in your previous courses, you cannot divide by 0 or else it's going to be undefined, okay? So that's the number 1 reason why you should not just plug in the number that you're approaching, okay? You want to get arbitrarily close but not exact. Now, we're going to explore why it comes out to 1/2 later algebraically, and I'll show you that in a different lesson, okay? But that's the reason why we don't just plug in the number, okay? You want to get arbitrarily close, okay? All right, so here's the graphic part. This is what it looks like graphically, okay? As we get closer to 1, if you notice the graph, there's actually a hole there. So does that mean the limit doesn't exist, right? So remember the definition is the y value as x gets arbitrarily close to a on either side of a, but not exactly a. So even though there's a hole here, you guys, even though there's a hole, doesn't matter because we're just getting arbitrarily close to it. Okay, so whether there's a hole or not, it doesn't matter. We just want to get close to it. So I'm showing you the table and the graph at the same time because you guys really have to understand what a limit is from all different perspectives. Okay, so we're not learning a lot of concepts, but we're just learning a few concepts from several perspectives. Okay, this is how you guys get really good with the concept here. Okay, all right. Okay, I'll leave this one up here. Call this example 2. This is one for you guys to try as well. Okay. Pause there. Go ahead and try it. And when you're ready to move on, press play. Okay. Okay. So now that you've had enough time, here you should have gotten something really close to about 0.1667. Okay. They kind of cheated here. They didn't write out all the values. They kind of just wrote the plus or minus version just because we're approaching the left and right side of 0. So it's convenient. But 0.1667 is actually 1/6. You don't need to know that, but I'll share with you later on why it comes out to 1/6. Okay? Okay, let's move on. Now, reason number 2 on why you should gradually get closer to the number you're approaching. Let's say you're approaching 0, okay? And I was this way too when I was in school. I thought, well, if you're approaching a number, why not just get super close, right? If you type in, let's say you wanted to just go on your table and type in 0.00000001. If you type that in, you actually get 0.000, okay? Which is not what the answer was. It was 1/6. And the reason why is when you get so small, okay, the calculator rounds your answer. And when it rounds it too early, it throws off your final answer. Okay? So the reason is you want to get arbitrarily close because you're really studying the behavior of your y values. You're trying to see what the y values are slowly turning into. Now, how are you going to study the behavior if you're just jumping straight to the closest value, right? So this is the reason why you want to get arbitrarily close, okay? Now, you're learning of the numerical approach. This is how you guys are making a table, right? The numerical approach only goes so far. So just keep that in mind, which is why you have to look at different perspectives, okay? So here we go. Let's continue. And I'm moving on because we already talked about it, okay? Don't think I'm skipping anything here. Okay, so some notation that you guys have to know. A limit, okay? And you guys have had practice writing out this limit here. So the limit of f of x as x approaches some number a will equal some value. Now, your limit will only exist if your left limit and your right limit comes out the same. So in the last few examples, I had you guys plug in values from the left and from the right of that value, okay? So the notation here is, let's say I wanted to approach 2 from the left. You guys would write the limit of f of x as x approaches 2 from the left. It kind of looks like an exponent, okay? It's a superscript. So that just means from the left. And if you want to write the limit of f of x as x approaches 2 from the right, you just put the plus sign, okay? We will use that very often. It's just notation. That just tells me, okay, so which side are you approaching it from? Now, if you see a limit that doesn't have any notation up here, that pretty much means you have to check both sides, okay? Because that's what a limit definition is. Okay, so here we go. Here's example 3. Okay, I know it says example 7 there, okay? So here, what I want you to do is to first draw out this picture, okay? I'll pause here and play whenever you're ready, okay? Okay, so we're going to find a limit graphically now. So we're not going to make a table, okay? So you're putting on a different hat right now. You guys are finding the limit graphically, okay? But that doesn't mean the definition changes, okay? So again, it's very conceptual. Graphically is a lot easier, okay? A lot faster, but you have to understand the definition, okay? So here we go. Here's the first one. We're finding the limit of g of x. And g of x is defined as this blue graph here at the bottom, okay? Here we want to approach what, right? What does that mean? Pause for a second if you need to. Here, it's the limit of g of x as x approaches 2 from the left. Okay? That means from the left. So here is 2. So we want to approach the graph from the left of 2. So from the left of 2, we're on this blue graph right here heading this way. Okay? If you wanted to approach 2 from the right, you would be going this way. Okay? So here we go. So you follow the graph as x gets arbitrarily close to 2 from the left. Where does it go, right? So I'm going to go ahead and start at 0. Okay? So when x is 0, the graph is right up here. Okay? So this right now is when x is 0. And as x gets closer to 1, it gets to this value here. And as we get closer and closer and closer to 2, what do you guys notice the y value is? Right? Notice how that gets really close to the y value of 3. A lot easier than making a table on your calculator, right? So there are pros and cons to every approach. So here we go. Again, replay that if you guys need to. Part B. Here's the limit of g of x as x approaches what? 2 from the right side. So what's a number to the right of 2? 3 or 4 or 5. It really doesn't matter. But remember, the definition is we're trying to find the y value as we get really close to 2 from the right side. So I'm just going to start here at 4. It doesn't matter where you start. Okay? And we're going to slowly try to get closer and closer to 2. Now, if you notice, when we get really close to 2, what is that y value? Okay, that y value there is going to be 1. Okay, now remember, does it matter if there's a hole there? Okay, and I'm hoping your answer is no, it doesn't matter. Okay, it doesn't matter because we don't care about what happens exactly at that moment, because that's what a limit is. Okay? Okay, so here we go. Part C. Now, notice that they're asking us for the limit of g of x as x approaches 2. And some of you might be asking, well, they didn't tell us from what direction, right? Now, remember, what does that mean if they don't give you a direction? That means they want you to check both. So what did we get when we approached 2 from the left, right? We got 3. And what did we get when we approached 2 from the right? We got 1. Okay, so if you guys go back to the very first line of your definition, what does it say, right? The limit is the y value. Notice how value is singular, right? So what do I say here? The limit is 3. The limit is 1. 3 and 1, right? So because it's singular, that means that there has to be an agreement. Okay? When you approach it from the left and the right, it has to be the same value. Now, since the values are not equal, what you're going to say is you're going to get rid of this equal sign now. And you hear this phrase a lot, and this is where it comes from. The limit here does not exist. Okay? Anytime a limit does not exist, you have to justify it, okay? So here's what you're going to say. The limit here does not exist since the limit of, g of x as x approaches 2 from the left does not equal the limit of g of x as x approaches 2 from the right. Okay? When the two left and right limits do not equal, the overall limit does not exist, okay? Pause, replay that if you guys need to, okay? Okay, here we go. I'm going to make some space here because we're going to do parts D, E, and F. Okay, so here, you guys can try it. X is approaching 5 from the left, 5 from the right, and 5. pause here, try this out on your own, and when you're ready to play it, I'll show you the answers, okay? Okay, here we go. So when you're approaching g of x, as x approaches 5 from the left, as you get arbitrarily close to 5 from the left, it's looking like the y value is about 2. Okay? Okay. It looks a little bit shy than 2, but whatever. Okay? If you approach 5 from the right, you also get 2. So what's the limit of g of x as x approaches 5? Since the two limits equal, you could say that it equals 2 as well. Okay? If you got that, great. If not, go back and check to see why. And I'm going to move on. Okay? Okay, so last part. You have to know the difference. So remember, the limit of a function is, and I'll pause there. You could fill it in, and you should write these out. Y value as x gets arbitrarily close to some number a on either side of a, but not exactly a. So when you're studying limits, notice how every single component of this definition comes into play. Okay, all 4 lines here. So the limit of a function is when you get really close on either side, but not exactly at that moment. Okay? And it looks like the limit of f of x as x approaches a equals some number. Okay? That's the notation for that. Now, a defined function is the same thing. It's the y value when x is exactly a. Okay? So all those times where we didn't care about what happens at that moment, that's what a defined function is. Okay? So a defined function is the y value when x is exactly at that moment. So a defined function, you're not studying the behavior. You're not getting super close, right? You just care about what happens at that moment. And it'll look like this, like f of a equals some number. Okay? And I'll show you. Here we go. This is the same picture. Okay? So don't draw it out again. We're just going to call this part G, H, and I. Now, when it says G of 0 here, okay, they're telling us, well, what happens exactly when x is 0? So if you take a look, when x is 0, what's the y value? Okay? Now, we can't be for sure, but G of 0, what would you guys say, right? I would say that that's about 2.5. Okay? So remember, these are all defined functions. These are not limits because there's no limit notation. So pause here. Figure out what G of 5 and G of 2 is. Okay? And when you're ready for your answers, press play. Here we go. G of 5, remember, it's the y value when x is exactly 5. When x is exactly 5, it's looking like it's at 1.2. When x is exactly 5, it's defined right here. Right? Okay? You wouldn't say this whole here because it's not defined there. Okay? So G of 2, when x is exactly 2, what's the y value? Okay? So if you notice here, there's no dot or there's no defined point. So what's the answer, right? So I would go ahead and erase that because there's no equivalent value. Is undefined. You could also say does not exist. They're pretty much the same thing there, okay? If you got that, great. If not, if you have questions, please let me know, okay? Okay. Okay. Let's call this example 4. We're going to talk about this real quick. Write this down. Find the limit of 1 over x squared as x approaches 0 if it exists. Okay. So you're going to just watch this one here, okay? We're not going to physically do it. So what we're going to do is we're going to get really close to 0 from both sides. And since 0 is the value that we're approaching, the left and right sides will have the same values, just the plus or minuses are different. So notice how when I plug in 1 or -1, I get this value. And then remember, for a limit, we're studying the y values, right? Now, if you guys take a look here, what do you notice as we get really close to 0, right? As we get really close to 0, are the y values getting really close to something? Okay, so this one's a little bit weird. Let me go back to the other one so you guys can see. Here, in this example, you guys just did this. When we got really close to 1, the values got really smushed into a 0.5. So it got really close to it, right? Same thing as if we were to approach it from the right side. But now here, it's weird because it's not getting really close to a number. If you notice, the number is just getting larger and larger and larger, okay? Now graphically, take a look. As we get closer and closer to 0, that kind of makes sense. The number just gets larger and larger and larger. Now, where the heck is it going? Right? So, if you answer correctly, it's infinity. Right? If we approach it from the right or if we approach it from the left, it's going all the way to infinity on both sides. So, do we say that the limit of 1 over x squared as x approaches 0 is infinity, right? And this is where some authors disagree, but I'll tell you what I think is right, okay? If you go back to your definition, the very first line says what, right? It's the y value. By definition, a value is a number. It's finite, right? Infinity is not a number. So even though we're approaching from left and right and they're both approaching infinity, infinity is not a value. So instead, what you guys would say is, does not exist. All right? Cool. Let's move on. Here's the last one, and we'll end the video here. So oftentimes, you guys will see a piecewise function. It'll have this little brace here. And actually, if you go back to this last example, this right here is a piecewise function. Piecewise function. That just basically means that your function is broken up into many pieces, okay? So this is what it looks like graphically, and this is what it looks like as a function, okay? So sometimes they'll pose a question like this. And again, make sure you write this down. We'll call this example. I think we're on 5. Suppose they ask you, what's the limit of this function as x approaches 1 from the right? Okay? So here's what you have to think about. And I'll draw a number line for you, okay? If you're approaching 1 from the right, what's a good number to start with? Right? So a good number to start with is maybe 2 or 3 or 4 or 5 or 6 or any number that's greater than 1, which is this right here. So if you're approaching 1 from the right side, you're approaching from numbers that are greater than 1, so you would be focusing on this function here. So you would be taking the limit as x approaches 1 from this function. Okay? And then you would play that numerical game. Get arbitrarily close to 1 from the right. Okay? So if you plug in 1.0001, you should get 1 here. Okay? Now, what if I ask you what's the limit of f of x as x approaches 1 from the left? Give me an example of a number that's 1 from the left, right? So an easy number would be 0. Okay? Now 0, okay, is definitely less than 1, but it's also greater than negative 1. So you want to choose this one and not this one here, okay? So 0 is somewhere between negative 1 and 1, so we're going to play with this function. So this is really just the limit as x approaches 1 of x squared. And if you play with your table, or if you graph it and look, if you approach 1, you should get 1 as well. Okay, we will practice this later. This is just an introduction for you guys. So the last thing I want to say is, does the limit of f of x as x approaches 1 exist? Okay, pause, think about that there and answer it. Okay, so your answer should have been, yes, it does exist. It exists at 1 because the left limit and the right limit are actually the same. Okay, so that's it. So to conclude, remember, do you know what a limit is? Okay, you could recite the 4 lines. Okay, do you know how to find a limit graphically? Yeah, you just stare at it and you follow where you need to go, right? Do you know how to find it numerically? Yep, you just make a table and you get arbitrarily close on either side. And that is it, you guys, okay? Go ahead and practice your homework. It is posted. If you have any questions, let me know, okay?